Time, position, velocity. Write a story to match the graph. Find total distance and average speed for the trip. Well, this was a problem for you in the last video. Here are some of my suggestions. I looked into the answers and found that in many of the cases, details were missing. Well, you can always write a story to explain the situation, but more details you give, better it is. It is easier to provide details if you label your graph. So I'll give you some tips which will help you to describe any graph for that matter. Now, this time graph, we are kind of extending the example which we had, trip to corner store. So let's think about a person and let's give him a name. For example, we can call it Tom. Let's say Tom starts from home, goes to a corner store, buys something and comes back. Now, in short, that is the story. Now, to explain the story better, what we can do is we can label each point of our interest. For example, let's say this is the home, the starting point, 0, 0. We can label this as A. And that's the turning point. Let's call it B. This as C, D, E, F, and G. So these points breaks down the graph in different legs, right? Then it becomes easier for us to explain or write a story depicting the displacement with time. Now, another thing which helps us is to find velocity at different intervals or during different segments. As you can see, you can always read distance and time from the graph. Now, the ratio of distance and time or change in distance over change in time gives you the speed. Now, if you look into the segment AB, you find that in the first 4 seconds, a distance of 200 is covered. So, speed on this leg of AB will be 200 over 4. So, we can write speed on AB as 200 change in distance over change in time, which is 4, right? So 200 divided by 4 is 50. Units are meters for distance and minutes for time, right? So initially, we can say Tom leaves the house and steadily walks towards the corner store at the speed of 50 meters per minute and covers a distance of 200 meters in first 4 minutes. Now this part of the story reveals a lot of material, right? Very relevant information and makes the things detailed and better, right? Now what happens at B? This is the turning point. So probably Tom forgot something, right? Maybe money. So you can add Tom forgot money and decided to rush back home. Now, rushing back home means returning distance of 20 meters in this span of time is just 2 minutes. So we say speed along BC is actually, we'll write minus and we call it velocity. Velocity is vector, speed is scalar, right? So when we say speed, we are normally only concerned with the magnitude and not the direction, right? You can say rushed back home with the speed of. That is also kind of negative velocity, right? So in this case, distance of 200 meters is covered in 2 minutes. And therefore, the speed will be 200 over 2, which is 100 meters per minute, right? So like this, we can give more details to our graph and the story. Now from C to D, the speed is 0. That means he collects the money in 2 minutes, right? And then goes walks towards the corner store, right, and goes straight to the store. And D to E is a distance of 600 meters, which is covered in 4 and 4, 8 minutes, right? So we see that C to D, speed is how much? Speed is 0, right? And then from D to E, speed from D to E will be 600 divided by 8. If we use the calculator, 600 divided by 8 gives us 75 meters per minute, right? So we can continue with the story that Tom started from home at a steady speed of 50 meters per minute, covered a distance of 200 meters in first 4 minutes, and then realized that there was no money with him, so returned back home with a speed of 100 meters per minute, covering the same distance 200 meters in just 2 minutes. He takes money which took him 2 minutes and then walks towards the store with a steady speed of 75 meters per minute. So it takes 8 minutes to cover a distance of 600 meters to reach the store, where he buys milk or whatever. He stays in the store for 4 minutes and then walks back home, covering the distance of 600 meters in 4, 8, 12 minutes. So the speed along F and G is 600 divided by 4, 8, 12. Each unit is 4, right? 12. And so it is 600 divided by 12 will give us 50 meters per minute, right? So, calculating speed helps us to describe the graph better. To add more information, what we can do is, we can say that the average speed of Tom was, total time taken was 32 minutes, right? So average speed was, first let's calculate the total distance, right? Distance traveled was 200 and 200, 400. 400 plus 600, 1000. 1000 plus 600, 1600. So total distance covered was 600 meters, and this was covered in a duration of 32 minutes. So we'll divide that by 32 minutes, right? So 1600 divided by 32 gives us 50 meters per minute, right? The speed of Tom of going to the corner store, purchasing milk and coming back was 50 meters per minute. And we can say, well, Tom completed the whole job in 32 minutes. So like this, we can describe our graph in so many different ways. Providing details, especially speed calculation, helps us to give a better description of the graph. So I'll appreciate if you do that, right? And you can also signify that during the time when he reached the store, during the time he shopped at the store, and the time taken while coming back, correct? So all these things can be described from the graph and can give you better marks. Thank you.